See Lindelof videos, implicit differentiation of a trigonometric function. First thing I would do here to take this derivative, Will, is I would rewrite. So I am going to use the chain rule here, but I actually would just rewrite this as x is equal to secant of y to the negative 1. Is that all right? Just as a way that I started this. Then I'm going to start taking the derivative here. So take d dx of this whole thing. d dx of x, of course, is 1. So 1 is equal to, and then the first derivative of secant is secant x tan x, isn't it? So I get secant 1 over y. I know I said I rewrote this, but I'm not going to do anything with this, so I'm going to leave this piece here. But then, and this goes to that question, then, because this is chain rule, I need the derivative of the inside, right? Well, the inside is this piece right here, isn't it? So I need times d dx of y to the negative 1. So what I'm going to do first is I'm going to look at this as the chain rule. So I'm going to take the derivative of the outside, which is negative y to the negative 2. Is that all right? And then after that, what I have to do is, and this is where people get caught, because this y prime shows up, and they're like, where the hell did that come from? Well, it comes from here, because now I have to take the derivative of the inside of this, don't I? And the derivative of y is the derivative of y, which is y prime. So I'm just going to go back and rewrite this as 1 is equal to secant 1 over y tan 1 over y times, and then if you don't mind, I'm just going to clean this up, and I'm going to put y prime over y squared. Everybody okay with that? The negative sign that was here, this negative sign is here. I cured the negative exponent. Everybody all right with all that stuff, all that mess? So from here, and then I get, this is actually what I did here, as I put this whole thing, I put this whole thing like this. Actually, this negative sign, well, I can bring the negative sign out to the front, right? And where did I go from here? Oh, I can cross multiply here. I'm going to use means extremes here. I'm going to cross multiply here. That brings this, so I'm going to multiply, so I'll get y squared, so I'll leave the negative sign with it, is equal to secant 1 over y tan 1 over y times y prime. Still pretty good, isn't it? Then I'm going to divide by this whole piece right here, because the whole goal here is to get y prime by itself. So here's my goal here, Austin, is to get this y prime by itself. So I'll divide by all that, and I'll get y prime is equal to y squared over secant 1 over y tan over 1. That. Is that all right? Now the deal here is we can actually clean this up more. This is a correct answer, but we know that secant is 1 over cosine, isn't it? We know that tan is sine over cosine. So we can bring those things up, so we can get it out of this rational form, and it comes up this way, that y prime is equal to negative y squared cosine 1 over y. That's from me bringing this up, Austin, times cotan 1 over y, and also that's from me bringing this up, right? I'm using theorem of complex fractions here, right? And that's my answer.